Hey everyone, welcome to class. I am Big Phyllis, and today we are going deep into digital world, the part where most people never think about. You see, every app, every website, every photo you have seen on your device, they all run on something extremely simple, zeros and ones. Yeah, I know that sounds strange, but stay with me. By the end of this video, you will understand exactly how your computer reads words, number, or even images. Let's start with the basics. Inside your computer are billions of electronic switches called transistors. Each of these switches can be in one or two states, on or off. When it's on, the computer represents it as 1. And when it's off, it represents it as 0. And that is what we call binary digits, or simply bits. Every single thing your computer does, every sound, every color, every key you press is presented in this simple language, zeros and 1. Let me show you something on the screen. Now, you don't have to read that. Just look at it. That is how your computer sees the word hello. Each block of 8 bits here, we call it bytes, and every byte represents one character. So, a single letter like H doesn't exist in your computer the way you see it. It exists as a combination of on and off signal, a unique pattern of zeros and 1. Now here's a catch. Binary numbers can get really long and hard to read. Imagine trying to debug or write code using zeros and 1. That is like trying to read the entire novel written in Morse code. To make life easier, programmers use number system called hexadecimal or just X for short. Hexadecimal is based on 16 symbols instead of 2. It goes like this: 0 to 9 and A to F. The letter A to F represents number 10 to 15 in decimal form. Why 16? Because 16 fits perfectly with binary. Every 4 binary digits equals 1 hexadecimal. Let's put it to practice. We have our character, the binary, and the X equivalent of the word hello. The word hello that looks scary in binary with plenty zeros and 1 now becomes this clean and compact. 48, 45, 4C, 4C, 4F. Much better, right? That is why programmers love using X. It's just a human-friendly version of binary. Now you might be thinking, okay Felix, I get binary and I get X. How does the computer actually know that 01001000 means the letter H? The answer is ASCII, pronounced as ASCII. Let's say it together, ASCII. ASCII stands for American Standard Code for Information Exchange. It is a universal system that gives every letter, number, and symbol its own code value. So, every time you type a letter on your keyboard, your computer checks the table, converts the character into the ASCII number, and then stores it in binary form. It's like your keyboard speaks human and your computer speaks binary, and the ASCII is the translator between both of them. Now let's bring it home. When you open a text file, when you code in HTML or Python, or even when you send a message, all those letters are just binary code representing the ASCII character. In web development, when you see something like percentage before 20, it is representing your space, or percentage before 41, it represents the letter A. Those are actually hexadecimal representation of the ASCII value. Even the way you speak ancient binary language in disguise. Isn't that funny? Alright, let's continue. To summarize what we have learned so far, binary base 2 is what the computer truly understands, zeros and 1. Hexadecimal base 16 is how the human makes that binary easier to work with. Then the ASCII gives those binary numbers meaning, turning them into readable letters, numbers, and symbols. Everything you see on your screen today, every emoji to emails, starts from there. Let's test your brain a bit before we wrap it up. If the ASCII code For the uppercase, letter A is 65 in decimal. Can you tell me what would it be in binary and in hex? Alright, here is your answer. In decimal, it will be 65, which is equal to 01000001 in binary and 41 in hex. That is the letter A. Simple, but so there you have it. Your computer doesn't see color, sound, or even text. It only sees zeros and one. But with the help of hexadecimal and ASCII, humans can communicate with machines in a way that makes sense to both sides. That is the beauty of digital logic. Simple idea forming the foundation for modern technology. If you find this class helpful, hit the like button, drop a comment, tell me what you think, tell me what video you like me to talk about on binary equivalent. And don't forget to subscribe to my YouTube channel for more tech lessons explained in plain English by your boy, Big Felix. See you in the next class.